Water, an extraordinary substance. It is extraordinary. It's really the only liquid, no, not the only one. But you think about a pure substance that is a liquid that you run into in everyday life. Can you think of one besides water? A pure substance, a compound or an element that is a liquid at room temperature that you encounter in your everyday life. Can you think of one? Most of the liquids we encounter are actually solutions with water as the solvent. And even if you think about gasoline, well, gasoline is not a pure substance. It's a mixture of a bunch of different substances. You think of, vegetable oil. Okay, that's a liquid at room temperature. Again, a mixture of many substances. And even if you include those mixtures, there still are not many things that are a liquid at room temperature. So just being a liquid is kind of weird. We know that water is essential for life. It has a low molar mass, and yet it's a liquid at room temperature, and that is all due to the hydrogen bonding. It's often called the universal solvent because it just, so many things dissolve in it, and it's used for so many things. Not just, what we do with it, but what it does for us. It's the solvent in living organisms. It's the main solvent in our environment. Fats and oils and things play a part as well, but water is definitely the main solvent. It has an exceptionally high specific heat capacity, and this has a huge impact on climate and the livability of our planet. The other weird thing about water is it expands upon freezing, and that's very atypical for substances. We looked at this graph when we looked at hydrogen bonding, and we see as we compare boiling points for homologous compounds, meaning they all have the same general formula, and the difference is the elements are in the same group in the periodic table. So blue, these are all group 6A, and the yellow is group 5A, and here's 4A. And we see this nice trend here. This one, now ammonia jumps up a lot like water did. Why does ammonia do that? Can ammonia do hydrogen bonding? It can participate in hydrogen bonding. Remember ET phone home? Do we have nitrogen-hydrogen bonds? Polar molecules? Yep. So ammonia does hydrogen bonding, and so its boiling point is much higher than would be predicted. We'd predict something down here. HF, the green line that's kind of hiding in here, those are the halogens. Does hydrogen fluoride do hydrogen bonding? HF. So he also jumps up. And then here's our friend water. The water has by far the highest boiling point of all of these guys. So ammonia boils below room temperature. Hydrogen fluoride, 25 is usually room temperature. That boils a little bit below room temperature as well. Little blurb in the book about water pollution. I'm not going to test you on this, but it's important to think about. We need to have clean water. It's critical. There are different types of contaminants in our water. One is biological. Biological contaminants, these include microorganisms that cause disease. And these usually enter drinking water when you have animal or human waste that's dumped into large bodies of water. It can also happen through leaching of the microorganisms from like a nearby pasture into the water. This is where some of those produce recalls come about because there was a a pasture upstream and the cows do what cows do, and then microorganisms get in the water. That water is used to irrigate strawberries, and then you've got bacteria on your strawberries. Not good. You can treat microorganisms and biological contamination either chemically or by boiling. Boiling doesn't kill all of them, but it kills most of them. Then you have chemical contaminants, and these are coming from industrial and household dumping, pesticide and fertilizer use. The fertilizer you put on your lawn, well, your grass doesn't soak up all of it, and some of it runs off, and then that water runs down the street and into the sewer and into the river. A lot of these chemical contaminants are not volatile, meaning they're not going to vaporize easily on their own, and so they're going to stay in the water. And because they are not alive, they're not going to be eliminated by boiling. So you can't clean chemicals out of your water by boiling it. Now, if you distill the water, you can clean it that way, but that's a pretty involved process.